All right, so for the quadratics, linear and quadratics exam review, these are pulled straight from the test. X squared minus 9x plus 20. So the first one is a basic factoring problem. So you're looking at what multiplies to be the last number and adds up to be the middle number. I like to use just a little visual representation here. Whoops, wrote it wrong. Multiplies to be 20 and adds up to be -9. Your answer is always going to break down to two binomials because x times x is x squared. And then you say, well, multiplies to be 20 and adds up to be -9. I know this one's not hard, but if you do get stuck on one of these, just start going to the calculator. 20 divided by 1, 20 divided by 2, 20 divided by 3 is a decimal, 20 divided by 4. Oh, that looks pretty good. So just start dividing it by 1, 2, 3, 4, and just write them out, okay? So -4 times -5 would be +20. -4 plus -5 would be -9. So I write -4 here, and I write -5 here. You can FOIL to check your answer. This is like a normal test to where you can go back. Like you can answer them all and then go back and like look at the ones and check your answer and things like that, just to make sure you have enough time. But it never hurts to like just check your answer when you do these problems. The second one, I think, is a little bit of a harder factoring problem. 3y squared minus 6 equals -7y. (3y squared minus 6 equals -7y. That was just 6, wasn't it? Let me make sure I do these right because it's not going to factor nice if I don't write it right. Okay. All right, so this one has an equal sign in it, but I am going to, I want to make sure that I get everything on one side, so I'm going to add 7y to both sides. So I have 3y squared plus 7y minus 6 equals 0. So when you are factoring steps, how do you even know if you're factoring, if you're doing a quadratic or if you're doing an equation, if you're working a problem? If it has a y squared and a y in it, when you see a y squared and a y, it's most likely going to be a factoring problem. So the first step of factoring is set it equal to 0. Then we check for a GCF. I cannot divide 3, 7, and -6 by anything besides 1. So how you factor this, you can do factor by grouping. You can do the AC method, check and guess and check. The way that I do it, 3 times -6 multiplies to be -18. So what is, we multiply it because there's a number in front of the x squared there, or the y squared. So what multiplies to be -18 and adds up to be 7, that would be +9 and -2, right? 9 times -2 is -18. 9 plus -2 would be -7. Okay, so if you're doing factor by grouping, this is where we go a little bit differently here. The way that I do it, though, is I would write 3y at the beginning of both of these. I write 3y at the beginning of both of them because I multiplied by 3y to start. Okay, multiplied by 3y to start. And then I write my +9 and -2. So kind of the same setup as what we did on number 1. But this obviously isn't right because if I folded it, it wouldn't work out. But I can divide 3 and 9 both by 3 and just get y plus 3. 3 and 2 I can't divide by anything. And now if I fold it back out, it would work. What happens here is I multiplied by 3 at the beginning, so I divide by 3 at the end to make it back to where it was. Okay. We're not quite finished with this problem yet, though, because we do need to, it has an equal sign in it, so we set both factors equal to 0. On this one, we just subtract 3 from both sides. And on this one, we add 2 and then divide by 3. So you could FOIL it to check it. You could, you could FOIL this right out here to check it. You could also take those numbers and plug them back in to check it. So anytime you have an equation, you can always do that. It's always nice to know that on a test, if you're questioning your answer. By the way, as this loads right here, I don't know, maybe I should have reconnected my Wi-Fi because it was struggling there. All right. Number 3, I'll say that in a second. Number 3 is on your test work page. Okay, so I'm going to write on test work page. I'll come back and... So what I want you to do is just kind of pay attention to the numbers that you have on this page right here. And if like 3, 4, 5, 6, 7, 9, like I guess most of them right there at the end. I just want you to show your work on this problem right here. So what was it? It was u minus 2 minus 28. Okay. So I want to see your work for this problem. So this is something squared minus 28. So the first thing I want to do is get that something squared by itself. Okay. Now I have something squared equals a number. Something squared equals a number, so I can do the square root of both sides. The square root and the square cancel each other out, and I get u minus 2. The square root of 28. It does break down. We did a little bit of this when we did this, but 4 times 7 is 28. 2 times 2 is 4. So the factors here are 2 times 2 times 7 would equal 28. So the 2 comes out and the 7 stays in. The 2, any pairs come out. The pair comes out. So you have a pair of 2, so they come out. The 7 stays in. What about... Went blank there for a second. When I do the square root inside the equation, what do I have to put? I have to put plus or minus, okay? So anytime you do the square root of the equation, you have to put plus or minus. And then lastly, to solve this, to get u completely by itself, I add 2 to both sides. So 2 plus or minus 2 square roots of 7, not 27. All right, number 4 is on the show your work page as well. 3x squared minus 3x minus 5 equals 0. 3x squared minus 3x minus 5 equals 0. I will give you this formula. I should have put it on the work page right there. That would have been a smart idea. But I will give you this formula. It says in the instructions of the problem to use the quadratic formula, so you know it's not going to factor, so you don't have to waste your time trying to factor. So the quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I should have put it on the page, but remind me, and I will put it on the board. All right, so a equals 3. A is the number in front of x squared. B is the number in front of x, so it's negative 3. And c is the constant by itself, so it's negative 5. So I do the opposite of b. Opposite of b is positive 3 plus or minus b squared minus 4 times a times c all over 2 times a. If you happen to run out of room, you can always use the back of your page too. You don't have to write the formula on there. It'd save you a bunch of room. All right, so what I do on these to make these a little easier is I go start working the square root on the side. So 3 squared. Oh, wait, that's negative 3 squared, isn't it? Glad I saw that. Not that it matters, because negative 3 times negative 3 would be positive 9. But that is negative 3 squared for b squared, so that's 9. Negative 4 times 3 times negative 5 would be positive 60. So that would be the square root of 69. The square root of 69 does not break down because 23 and 3 are both prime. So there's not a pair there. So my answer actually is, well, this will be my answer. 3 plus or minus the square root of 69 divided by 6. You do not simplify the 3 and the 6 because you have this term right here. You would only simplify it if there was a number out here and a number, those 3 numbers with my 3 little circles. You would only simplify it if a number outside the radical and those 2 could all be divided by something. So all 3 of them have to be divided by something. And I'll say this now on this problem, Alex is pretty good about like giving you partial credit on a problem like this if you didn't simplify. But after the test, this is algebra, computer math is not perfect. You are welcome to go review your test. Like, you don't have to do it immediately after. You can do it the weekend, that's fine. And just, if you go back and review your test and look at the problems you missed, and you say, man, I forgot a negative here, or I just forgot to reduce it, you can tell me and I'll give you partial credit back, okay? You saw how slow my test is loading, so I do not go back and review your test individual question. That's why I have my test work page to look at, okay? Because it would take me like 5 hours to go back, and it's just slow to go to each question. So, number 5 is also on our test work page, isn't it? Okay, so on this problem, I don't ask you to show your work. Actually, that's the way I'm going to do it too. Because there isn't as much room. This is kind of what I'll do on some of these problems. Instead of having you show me everything, I just want you to show me my answer here. 2x minus 3 less than or equal to negative 9. You are welcome to show me more than I need, though. 2x minus 3 and 3x3 less than 6. Okay, so I'm not going to expect you to show this part on the test, but you're welcome to do it if you want to. All right, so I got to solve each of these before I even talk about all the other stuff. So 2x, add 3 to both sides. Negative 9 plus 3 is negative 6. Divide by 2. X is less than or equal to negative 3. You only flip the sign if you divide by a negative, okay? Not when you're dividing a negative. It's when you divide by a negative. Here I'm dividing by 2, so I do not flip the sign. The one on the right, subtract 3 from both sides, so I get 3x is less than 3. Divide by 3, so x is less than 1. All right, so now I need to put this on a number line and say my answer is what my worksheet says. Oh, this says write the solution in interval notation. So this is the best way to do this. So again, you're welcome to show that part on the work page, but you do not have to. It says x is less than or equal to negative 3 and x is less than 1. I'll go ahead and rewrite that real quick so I don't forget it. Was it negative 1?
Positive 1.
Okay, positive 1. Okay, so this is all that I really want to see because this is what your answer is. So I have negative 3 and 1 on, I know you don't have different colors, but that's fine. This is the only way to figure out this answer too, unless you just really think about it, which just hurts the brain. So draw it out. X is less than or equal to negative 3. Okay, so x is less than or equal to negative 3 would be a bracket that goes forever to the left because it's less than or equal to. And then the less than 1 would be a parenthesis. And it's less than, so it goes forever to the left as well. All right. So now here's where your trick comes in, I guess, or why you got to draw it. It's and. So I want to know where the blue and the red line are. The only answer is where the blue and the red line are. If it said or, it could be any spot the red or the blue line are. So the and is I only want where the blue and the red line are. Blue and red line. So that would be this area right here, right? So it'd be less than negative 3. So negative infinity to negative 3 would be my answer. Okay. If it said or, I would actually do it from 1. This would be my answer. Because it could be on the red or the blue line. But here I want and means intersection. Where are the two lines intersecting? So that is kind of what I want to see on this page, is that you understand what you're finding for on your answer. Number 6 is a basic graphing one. This is on the work page. I guess we can go ahead and negative 2x minus 1. So h of x equals negative 2x minus 1. Here my slope is the number in front of x, which is negative 2. I say also write how much it goes up or down or how much it goes right and left, okay? So we've done this a lot when we were doing this. This would be down 2 because it's negative, to the right 1. Okay, that's just me making sure you understand what the slope is doing. My y-intercept would be negative 1. And my other question, what does x equal at the y-intercept, and what do we call that? X equals 0, and it is called, I'm going to call it our starting point. If you use something different word like to describe that, that's fine. But that is our starting point. When we think about what the y equals mx plus b in real life, our y-intercept is always our starting point. Okay, so that's something different than what I want, what the problem asks. The problem, it tells you to graph it. So I start at negative 1, and then I go down 2 to the right 1. Start at negative 1, down 2 to the right 1. So I start at negative 1, and then I went down 2 to the right 1.
Screen went out.
The screen went out. Hold on, I don't want to lose my work there, so give me just a second. What was this, number 7?
6.
Oh, I just wrote that in the wrong spot. I'll fix that later. Okay. So I started at negative 1, and I went down 2 to the right 1. So the y-intercept is your starting location. All right, number 7. I believe this is one of the harder ones, maybe. Oh no, can I not get, hold on, let me. Trying to make this as big as possible so y'all can see it. I'll zoom in a minute. I can make it bigger if you can't. If you're struggling seeing it. All right. This is just reading a graph of a parabola. Does the parabola open upward or downward? It obviously opens upward. Okay. So upward looks like this. Downward looks like this. A vertex. The vertex is the turning point. It's a different color here. The vertex is a turning point, so it is at 2, 1. My vertex is at 2, 1. The axis of symmetry always has to do with your vertex. It is the x value of the vertex. Okay? But be careful with that. You do have to write x equals 2 because the axis of symmetry is technically a vertical line that goes through there. Find the intercepts. So the x-intercepts is actually none. It never crosses the x-axis. And the y-intercept looks like it's at 5 right here. And I don't believe you write it as a point, you just write 5. So it is okay to have none. It's possible to have no x-intercepts. Most of the time you're going to have a y-intercept. Yeah, you always have a y-intercept. But you can't have 2 x-intercepts too if it crosses the x-axis. And I will try to make that bigger in just a second. We got to go to our work page too and answer some questions. Hold on before we answer that work problem. Let's go see what number 8 is. Can y'all see that a little better?
Mm-hmm.
You need it for a second? I'll pause. I feel like when I write it in my notes that makes it bigger, it doesn't show up on my webpage. I don't really know why. All right, I'm pausing on the show your work page for just a second because I want to look at number 8 because I have a feeling I accidentally wrote 7 and I meant 8. Yeah, scratch out number 7. I want that to be number 8. I want that to be number 8. Sorry. Because you answer those questions on number 7 anyways, so I don't want you to just have to write down the stuff that you already answered in Alex. My bad. So 3x minus 2 minus 7. So 3x minus 2 minus 7. I'm going to need to do this. I don't have enough room right here. But we don't need all that for the... What was it? Y equals. Okay, it's not a function. Okay, so we have to graph this. So let's just do the Alex problem first, and then we'll figure out the test work page problem. This is... There's a squared right here. This is in vertex form. The vertex form is y equals a times x minus h squared plus k. H and k are your vertex. I will not probably give this to you on the board because you don't really need to know that formula. What you have to recognize is you can just look at it and get the vertex. The vertex, the hard part about this is it is always the opposite of whatever's in the parentheses. So I know it looks like x minus 2, but the formula starts with a minus in it. So my vertex is just going to be 2, negative 7. Okay, so you can just look at it and get the vertex. The other thing that's nice to know here, I probably should have done this first, but that's fine, is does this one open up or down? So it opens up because A is positive. Okay, that kind of answers one of your test work problems. Actually, both of those answer your test work problem. All right, so to graph this, what do we have here? We got 2, negative 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. We have our vertex. It says in the directions to find your vertex and finds 2 points to the left and 2 points to the right. So if I want to do this, if I want to find 2 points to the left, then I can use the symmetry and do 2 points to the right. So you can pick any numbers that you want. Mine's at 2, so I'm just going to pick 1 and 0 and plug those in. So x equals 1, would be 1 minus 2 squared minus 7. That would be negative 3 minus 7 would be negative 10. Thought we said it opens up. Oh, it'd be positive 3. That's why it's nice to know if it opens up or down, because right there I was going to draw it to where it opens down, and we know that's wrong. So I just did a sign wrong. Like that's easy. That's why I always go through that, because I hope that like the reason you have to take math class is to think a little bit, and like critical thinking skills and problem solving skills. Like that is like, okay, we know it opens up. So if I get a point that's down here, that doesn't make any sense. I did something wrong in my math. All right, so 1, negative 4 would be right here, and then do x equals 1 or x equals 0. Three times negative 2 squared, and maybe I'll write some more steps out here so I don't make a sign mistake like I did last time. That's 5. Well, that jumps up fast. 1, 2, 3, 4, 5. Oh man, sorry. So the graph goes like that, but don't I know my axis of symmetry is right here at x equals 2? So I can just say, okay, this one's 1 to the left and up. From this point right here, it's 1 to the left and up 1, 2, 3. So what if I just go 1 to the left and up 3? Another one's 1 to the left up 3. What if I go 1 to the right up 3? The other one's 2 to the left up like, I don't know, 12. So if I go 2 to the right up 12, it's a little, whoa. 2 to the right up 12. Okay. So you really only have to find 2 points, and then you can use symmetry for the other 2. And it's a lot easier to do that on a computer and see that. All right, for the test work page, on my problem right here, we had a equals 3, so it opens up. My vertex, we can just look at it and get to negative 7. Probably would be nice if y'all wrote the formula on there, but that's fine if you don't. I didn't ask for it. And then what is the y-intercept? This is when we made x be 0. So what was it? It was 0, 5. Okay. If 0 is not one of the points that you plug in, it always should be because it's an easy number to work with, then you're going to have to actually plug in 0 on your own and find the y-intercept, but you just make x be 0 and figure out what y is. I'll write that right here so you see it when you come back. We already plugged it in, so we plugged in x equals 0 and already got our y-intercept. So I'll write that right here so you see it. This is our y-intercept. That yellow is probably hard to see, isn't it? Okay. What we got, like 2 more? What's number 9? I got to show my work on that page. What's number 10? Oh, okay. Number 9, 9x minus 4y equals negative 23. And negative 3x minus 2y equals negative 18. Negative 19. Okay, on this one, a system of equations. So we have to use algebra to find it. We got to manipulate the equations. Should we get rid of the x's or the y's? The y's, I can multiply the bottom one by negative 2 to make it positive 4 so that I can add up negative 4 and positive 4, make those cancel out. So I got to multiply everything times negative 2. So negative 2 times negative 3x would be 6x. Negative 2 times negative 4y. I'm sorry. Negative 2y, or negative 2 times negative 2y would be positive 4y. Negative 2 times negative 19 would be 38. Okay. So now what we are going to do is, I'm going to cross that out so it doesn't bug me. Add up the first one and the last one. 9x plus 6x would be 15x. Negative 4y plus 4y cancel each other out. And negative 23 plus 38 equals 15. Two things to kind of know if you do this problem correctly. The first one is one of the variables got to cancel out, right? You got to, when you get to this point, you should only have one variable because I want to make sure there's only, make it super easy to solve. The other thing is, Alex, usually, y'all can tell me if I'm wrong, but does not give you fractions. So if I get a number right there, that's not a fraction, you probably did it right. Okay, so now I'm going to take this and plug it in. You can plug it into any one that you want to. I've already crossed out that middle one, so I'm going to plug it into the top one. So 9 minus 4y equals negative 23. Negative 4y. Subtract that over. And I get negative 32. And divide by negative 4. Y equals 8. So these intersect at the point 1, 8. You really just need the x and the y. Again, I know that's a lot of work in just a small space. If it carries over to the back, that's fine. All right, so that's the last problem on the test work page. I need to... just in case you go back and try to work this problem, I want you to be able to see it. Last problem, number 10, is a graphing a linear inequality. Let's see. I think y'all are probably good enough with y equals mx plus b that I can just graph this, right? Top one, y is greater than or equal to 3x plus 5, so my y-intercept is 5. My slope is 3 over 1, so I go up 3 to the right 1. It is going to be a solid line because it's greater than or equal to. To shade it, if you plugged in a 0, 0 there, it would be 0 is greater than or equal to 3 times 0 plus 5. So 0 is greater than or equal to 5. That is not true, so I shade away from 0, 0. So if I was going to shade right now, I'd shade on this side. Okay? So I'm just going to undo that and remember that for a second. So I'm shading to the left of that, and the way it looks in my brain is to the left. All right. The other one, I do a y-intercept of 8, and it is down 3 to the right 1. This one is going to be a dashed line because it is less than. And to shade it, if I plug in a 0, 0, 0 is less than negative 3 times 0 plus 8. Is 0 less than 8? Yes. So I need to shade towards 0, 0. So on this one, I'm shading over here, but I got to be to the left here, so it should be right there. So again, just to say that, this one I shade towards 0, 0. And this one I shade away from 0, 0, so it's got to be right here. Oh, no. What did I do? Okay. All right. That is your test. Let me write a couple things here just because we didn't do that. So this one, y is greater than 3x plus 5. Y is less than negative 3x plus 8. Slope is 3. Y-intercept is 5. This is a solid line because it's greater than or equal to. When we plugged in a 0, 0 on this one, if y'all didn't... watch that. That'd be 0 is greater than or equal to. This is no, so we shade away from 0, 0. On this one, my slope is -3. My y-intercept is 8. It is going to be a dashed because it's less than. And when I plug in 0, 0 on this one, 0 is less than 8. That is yes. So we shade towards 0, 0. All right. Let me write this real quick. Shade towards 0, 0. Shade away from 0, 0. So it's got to be that one. Okay. All right.